Good morning, everyone. Today we are going to discuss about anticonvulsants. We'll discuss about the oxazolidinediones. So here we have trimethadione. So in oxazolidinediones, this particular class of compounds, they consist of the oxazolidine ring and the two keto groups. So it is oxazolidinedione. So this is a completely saturated oxazole ring. So it is called as oxazolidine, and there is two keto groups. So the hence it is called as oxazolidinediones. So in oxazolidinediones, we have two derivatives. One is trimethadione and another is paramethadione. So in trimethadione, it consists of three methyl groups which is being present, and in paramethadione there is in methyl group, and here it consists of an ethyl and a methyl group which is being present. So this oxazolidinedione or trimethadione, it is an anticonvulsant. It is used to treat epileptic conditions that are resistant to other treatments. That is, it is used in the treatment of different types of epilepsy. And this particular drug, it should not be given during the pregnancy period because it will cause trimethadione syndrome. So this trimethadione syndrome, it causes certain defects in the baby which is being born. That is, one is it causes facial dysmorphism, that is nothing but short upturned nose, slanted eyebrows. So there will be some defects which is being seen. Similarly, it also can cause some cardiac defects, that is related to the heart. Then it also causes intrauterine growth restriction, that is the baby's growth will not be proper as per the uh, schedule, and there also be mental retardation. So brain development also will not be proper, so it may lead to mental retardation. So these are the side effects which is related to trimethadione if it is being taken during the pregnancy period. So it should be avoided. Okay, so this is a anticonvulsant which is used in the treatment of different epileptic conditions, and it should be avoided in pregnant women because it causes fetal trimethadione syndrome, which can lead to dysmorphism, uh, cardiac defect, intrauterine growth restriction, mental growth retardation, etc. Now, paramethadione, we have seen already the structure of paramethadione. It is an anticonvulsant in the oxazolidinedione class. It is mainly used for the treatment of absent seizures, which is also called as the partial seizures. And this particular drug, it is a second line treatment for petit and absent seizures. So this paramethadione, it also has some side effects. So because of that, the use of this particular drug is also restricted because of its safety as well as the efficacy problems. Then adverse effects, what are being caused is, it causes sedation, increased visual sensitivity to light, then gastrointestinal distress, and it also causes severe birth defects known as fetal trimethadione syndrome when it is being used in pregnant women. So these are the uses of paramethadione. Okay, so it is mainly used in absent seizures, and it should be avoided in pregnant women because of the side effects which is being caused. Now the next class of drug that is called as the succinimides. So you can see here, these are the three different derivatives: phensuccinimide, then Methsuximide, and Ethosuximide. Okay, so either it can be called as succinimides or succimide. So both are same compounds. Okay, so you can see here, this is the pyrazolidinedione derivative. Sorry, it is a pyrrolidine. Pyrrole ring is present here. It is a pyrrolidinedione derivative, and it consists of substitution in the first portion and third portion. So you can see here in phensuccinimide, there is a phenyl group at the third position. So here numbering starts from this nitrogen, this is second, and this is the third position. Okay, so it consists of a methyl group and a phenyl group. So depending upon the difference in the substitution in the different portions, you get the different succinimides. So here you can see there is an extra methyl group. So that is called as Methsuximide. Then ethosuximide, it consists of an ethyl group here, and here it is hydrogen atom. Okay, so this is the structure of the three different succinimides. And when you take phensuccinimide, it is an anticonvulsant drug which can be used in the different types of epilepsy, which comes under the succinimide class. Now, if you take Methsuximide, okay, so this uses under a particular class, the uses are almost same. Similar uses will be seen. So it is a succinimide. It is an anticonvulsant medication, and this particular drug, if you take Methsuximide, it undergoes metabolism, and thereby it gets converted to the active metabolite, that is N-des-methyl methosuximide. Okay, so this is the active metabolite. This metabolite is responsible for the longer half-life and higher plasma levels of Methsuximide. Okay, so I'll repeat this point. So it is this Methsuximide, if it undergoes metabolism, and thereby it gets converted to a very active metabolite, that is desmethyl methosuximide, and this particular compound has a longer half-life and also a higher plasma concentration levels will be observed. Now, this particular drug, it is used for the treatment of absent seizures. So you can just come to absent seizures. What it is? Absent seizures, which is also called as the petit mal type of epilepsy. So absent seizures is a condition in which there will be not much body movements will be there. It will be like sudden onset impairment of consciousness. So in some cases, the person will lose a consciousness for a brief period, then interruption of ongoing activities. That is, they may be doing something, suddenly they stop doing that, and like if suppose they are starting writing something, they stop writing, and that whatever process they are doing, it will be interrupted. Then a blank stare, just they will be staring in a particular uh, direction without any much body movements. Then in some cases there will be brief rotation of the eyes, and that is mainly the person will become unresponsive for a brief period. So that is called as the absent seizure. So in some type of seizure there will be, for example, if you take in tonic-clonic seizure and all, there will be rapid violent jerking movements will be there, but in absent seizures there will not be much violent movements. Only it will be sudden impairment of consciousness, a brief loss of consciousness will be seen, interruption in the activities what they are doing, and in some cases the person will be just staring in a particular direction, and in some cases you can just see only there will be eye rotation of the eyeball or something, and the person will be unresponsive, and after the epilepsy period the person will become normal. So that is called as absent seizures. Okay, so this particular drug mainly it is used in the treatment of absent seizures. Now if you come to ethosuximide, it is a drug which is used for treating absent seizures. the similar, whatever the symptoms we have talked. It may be used alone or it can be used in combination with other drugs like valproic acid. Okay, so this is a monotherapy, or you can use this as a multi-therapy drug also. So this particular drug is a first line choice for the treatment of absent seizures, and it causes certain adverse effects like drowsiness, mental confusion, insomnia, headache. So these are all some of the effects which is related to this particular drugs. Now the next class, that is the miscellaneous compounds. So we have discussed about the different classes like barbiturates, benzodiazepines, hydantoins, succinimides, oxazolidinediones, etc. Then there are also certain other drugs which can be used in the treatment of epilepsy. So these particular drugs, they are categorized under the miscellaneous compounds. Okay, so some of the compounds in this miscellaneous category, they are related to the barbiturates or some other compounds, but they do not come under that particular category. Okay, so now we come to primidone. So primidone, this is a structure of primidone. So you can see here. So if you see, this is little bit structurally related to barbiturate. So in the second position, there is a if you take in barbiturates, in the second position, it consists of a keto group. Whereas in this, so this is the first position. In the second position, there is a keto group. That particular drug is called as phenobarbital. So here in this primidone, this the keto group at the second position is not there. Okay, it is saturated at this second position. So it is a 2-deoxyphenobarbital, that is called as primidone. So it is related, structurally related to barbiturate. It is a 2-deoxy derivative of phenobarbital, that is called as primidone. Okay, so this primidone is a drug which is used for treating partial and generalized seizures. So this particular drug, if it is used during the pregnancy period, it may lead to harm to the baby. So most of the anticonvulsant drugs, they will be causing harm to the baby. There are some drugs which can be used during the period also, if the mother is suffering from any epileptic problems. Okay, so it is an anticonvulsant. It is related to phenobarbital. It is a 2-deoxy derivative of phenobarbital. It is called as primidone. And it is an anticonvulsant which is used for essential tremors. So what is essential tremor is? Essential tremor is nothing but the involuntary rhythmic contractions and relaxations, that is oscillations or twitching movements of certain muscle groups. Okay, so here what essential tremor means, what it happens is there will be some involuntary rhythmic contractions. So you can just observe, they'll be shaking the hand or leg or a particular part of the body. Okay, either it may be the hands, limbs. It will be the limbs will be shaking in a rhythmic manner. It will be in the same manner, or in some cases you can see the neck movement will be there. Okay, so they'll be shaking the neck in a rhythmic manner. So like that, there'll be contractions and relaxation. So that is involuntary. So that cannot be controlled by them. This contractions, what happened, they cannot control that. Okay, so in some cases there'll be blinking of the eyes, in a rhythmic manner. It will be continuing till the epilepsy continues, and after that it will be only for a brief period, and after that they'll become normal. Okay, so this primidone, it is used as a monotherapy, or it can be used in combination with other drugs for the treatment of generalized tonic-clonic seizures, simple partial seizures, complex partial seizures, myoclonic seizures, and in juvenile myoclonic epilepsy, that is which affects the children. So in all these types of epilepsy, this particular drug can be used. Okay, so this is a drug which is used for partial generalized seizures and generalized tonic-clonic, complex partial seizures, myoclonic seizures, juvenile myoclonic epilepsy, etc. And this particular drug, it should be avoided in pregnant women since it will cause harm to the baby. Then now the next drug is valproic acid. So when you come to valproic acid, so valproic acid, this is the structure of valproic acid. So you can see here, this is the sodium salt of valproic acid. It is also a very important compound, sodium valproate. Okay, so mostly valproic acid, it is being given in its sodium salt. So this is the sodium salt, sodium valproate. Okay, so if you take valproic acid only, it is being called as Valium and all. So it is a broad spectrum anticonvulsant. It is used in tonic-clonic seizures, absent seizures, myoclonic seizures, and infantile spasms. Okay, so this is a broad spectrum anticonvulsant which can be used in different types of epilepsy, and it is being given successfully for status epilepsy by the intravenous route. Okay, so in case of status epilepsy, so status epilepsy is a type of epilepsy will be lasting for a longer duration, and there'll be violent jerking movements will be seen. So it is required to control the epilepsy fast. Okay, so otherwise what will happen is in some cases one type of epilepsy will be followed by the other type, and it will lead to paralysis of the hyperactive site if it is not being treated properly. Okay, so this is a drug which is being given by intravenous route in order to treat status epilepsy. And apart from this, it is also used for prevention of seizures in those who are suffering from absent seizures, partial seizures, and generalized seizures. And apart from those epileptic uses, it can also be used in the treatment of bipolar disorder, schizophrenia, and it is also used to prevent migraine headaches. So bipolar disorder and schizophrenia, these are the types of mental illness. So in those conditions also, this particular drug can be used to control the symptoms of those bipolar disorders and schizophrenia. So these are the uses of valproic acid. So it is a broad spectrum anticonvulsant which can be used in the treatment of different types of epilepsies. Okay, like even in children also, infantile spasms. Infantile spasm is the type of epilepsy which occurs in children. So initially it will be starting with a cry, and suddenly there will be brief loss of consciousness in the kids. So after that they will become normal. So in many cases what happens is, in kids who are born with some problems in the brain development, they will be showing initially some epileptic seizures. Then once the kid starts growing, this problem will be solved. Okay, uh, but in certain kids this will be seen. So in such children there will be learning disabilities also will be observed during their childhood. Now the next compound, that is a miscellaneous compound, gabapentin. So this is the structure of gabapentin. So this is a cyclohexane derivative. This is a cyclohexane derivative. It is mainly used in the treatment of epilepsy, and it is also used to relieve neuropathic pain. So it is mainly used in the treatment of partial seizures, then hot flashes. Hot flashes is nothing but in women after menopause, because the levels of estradiol hormone will be less. So because of that, what will happen is they will feel very hot. That is hot. That is called as hot flashes. And restless leg syndrome. Restless leg syndrome is nothing but some people, they feel uh, some difficulty in the legs, or they feel some kind of stress in their legs, so they'll be trying to shake their legs continuously. So what happens is, when they shake their legs, they will feel some comfortable kind. Okay, so what will happen is, so because of that, they will have difficulty in sleeping in the night. Okay, so it will lead to insomnia, sleeplessness, and all those things. So in such people, this particular drug, it is used to control the restless leg syndrome. And if you take this particular drug, it is structurally related to the neurotransmitter gamma aminobutyric acid, or GABA. Okay, and it acts by inhibiting certain calcium channels. Okay, so this is a drug. Gabapentin is mainly, it is used in different types of epilepsy, and it can be used to relieve neuropathic pain. And this is an anticonvulsant which is mainly used for treatment of partial seizures, hot flashes is which occurs in the menopause period due to decrease in the levels of the female sex hormone, that is estradiol. And in restless leg syndrome, so it can be used in that condition also. And it is structurally related to GABA, or gamma aminobutyric acid. So because of that, it will act by inhibiting, so it will mimicking in the action, and it will act by inhibiting the calcium ion channel. Apart from this, it is also used in the treatment of anxiety disorders, insomnia, then bipolar disorder, etc. So insomnia is nothing but sleeplessness, which can be caused because of the restless leg syndrome. Then it will also reduce the symptoms of alcohol withdrawal. So in this, the people who are addicted to alcohol, in those people, the withdrawal symptoms will be seen. So this particular drug, it will reduce the withdrawal symptoms, and thereby it will calm the person. The next drug is felbamate. So felbamate is an anticonvulsant which is used in the treatment of epilepsy. So it is used to treat partial seizures as well as generalized seizure in adults as well as in children. Okay, so this particular drug is also a positive modulator of GABA A receptors, and it also acts by blocking the NMDA receptors. NMDA is N-methyl D-aspartate receptors. And this particular drug has some side effects, like it can lead to anemia, and it can also cause liver failure on long-term use. So because of that, this particular drug's usage is also restricted. Okay, so this is an anticonvulsant. It is mainly used in partial seizures and generalized seizures, and it is a positive modulator of GABA receptors, and it acts as a blocker at the NMDA receptors. And side effects, it will restrict its use. Now the synthesis of ethosuximide. So this is the structure of ethosuximide. Already we have seen the structure, the succinimide class, and the uses also we have seen. Okay, so we'll come to the synthesis. So here this is the condensation reaction between ethyl methyl ketone. So this is the ethyl group, this is the methyl group. Ethyl methyl ketone, when it is being treated with ethyl cyanoacetate. So this is ethyl, this is cyanoacetate. So acetic acid is CH3COOH, right? So in this acetic acid moiety, when one of the hydrogen in CH3, one of the hydrogen is replaced by CN, cyano group, and the hydrogen over here in COOH, acetic acid. Okay, the hydrogen is replaced by ethyl group. So you get ethyl cyanoacetate. So when it is being condensed, it will result in the formation of this ethyl 2-cyano 3-methyl 2-pentanoate. The next step, it is being treated with hydrogen cyanide, in the presence of ethanol as a solvent. So it will result in the formation of ethyl 2,3 dicyano 3-methyl pentanoate will be formed. So this particular compound, it undergoes saponification and decar. So when it undergoes saponification, this ester will be converted into the carboxylic acid group. Okay. Then it undergoes decarboxylation, removal of the carbon dioxide, and then you will be getting 2-ethyl 2-methyl succinonitride. So succinic acid is nothing but CH2COH and CH2COH. That is called a succinic acid. So in this one of the hydrogen is replaced by cyano group, and here one of the hydrogen is replaced by, there are two hydrogens here, right? One of the hydrogen is replaced by ethyl group and one is replaced by methyl group. So you get 2-ethyl 2-methyl succinonitride. So this is the nitrile. Cyano group is nothing but it is called as a nitrile group. Okay. So this particular compound, when it is being treated with aqueous ammonia, it will result in the formation of the diamide. So both these positions, it will become the amide group. So this diamide, it will undergo cyclization by the loss of ammonia. Okay, so this will, here what will happen is, it will undergo cyclization by the loss of ammonia, and thereby it will result in the formation of ethosuximide. Okay, so this is the synthesis of ethosuximide, which is a succinimide. So again, I'll repeat this. So first, it is a condensation reaction which takes place between ethyl methyl ketone and ethyl cyanoacetate. So first step, it will form the pentanoid derivative. Okay, pentenoid. So this is second position, 1, 2, ene. Alkene is there. So that is only, it is 2, and the total number of carbon is 5. Okay, so it is 2 pentanoid. Then next step, what will happen is, it is treated with hydrogen cyanide. Addition reaction takes place in the presence of ethanol to form this particular compound. Next is saponification followed by decarboxylation. The next step, it is being heated in the presence of aqueous ammonia, so it gets converted to the diamide. Next is cyclization by the loss of ammonia. Okay, and thereby it will form ethosuximide. Next is the synthesis of carbamazepine. So you can see here in carbamazepine. So carbamazepine is a, if you see the derivative, carbamazepine is a dibenzazepine derivative. Okay, so carbamazepine, this is the structure of carbamazepine. Carbamazepine is a it consists of the immunostilbene nucleus, or it can be called as dibenzazepine. Okay, so this is the azepine ring, 7-membered ring, which consists of one heteroatom, that is nitrogen. So this ring is called as the azepine ring, 7-membered ring. It is being fused with the benzene ring in both sides. So this is called as the dibenzazepine ring, or it can also be called as a immunostilbene ring. Okay, so first step, we are taking the immunostilbene nucleus. It is being treated with acetic anhydride and N-bromosuccinimide. Okay, so NBS is nothing but it is N-bromosuccinimide. It is a very powerful halogenating agent, okay, which can be used. So when it is being treated, AC2O is acetic anhydride. Okay, CH3 CO twice O, that is acetic anhydride. So it undergoes acetylation and halogenation. Okay, subsequent halogenation. So here you can see here, it will result in the formation of the acetyl. So this nitrogen atom is acetylated. Okay, so here the acetyl group is coming, and here the bromination is taking place, bromine. Okay, then next step, it is being treated with quinidine. Okay, it is treated with a reagent called as quinidine. Okay, So here what will happen is when it is being heated with collidine, so this hydrogen, so in this particular position it is CH2, right? So this one of this hydrogen and this bromine, it will be liberated as HBr. Hydrogen bromide will be liberated, and here the bond will be coming. So you can see here this bond is here. The alkenic bond is created in this 9 and 10 position. Okay, now what will happen is the next step, in the presence of an alkali, it is being treated. So this acetyl group is removed, and thereby it will form the immunostilbene ring. Okay, so this immunostilbene nucleus, next it is being treated with phosgene, COCl2, that is called as phosgene, and it is being treated with ammonia. So in the presence of phosgene and ammonia, it will form the corresponding amide group. So this is the dibenzazepine carboxamide. Okay, that is called as carbamazepine will be formed. Okay, so first we take this dibenzazepine. Okay, the saturated form of dibenzazepine ring. First step is acetylation in the presence of acetic anhydride, that is CH3CO twice O acetic anhydride, and NBS is N-bromo succinimide. So thereby here the bromination will be taking place, and here it will be the acetyl group, the amino group is acetylated, and thereby it will form the acetyl group is coming. Next step, it is being treated with the reagent collidine. Okay, when it is being treated with collidine, what will happen is this hydrogen and this Br will be liberated as HBr, and here the bond will be coming. So here how it is shown here. The next step, it is being treated with an alkali such as sodium hydroxide. The deacetylation takes place, and thereby it will form the immunostilbene ring. This immunostilbene ring, next step, it is being treated with phosgene, that is COCl2, and ammonia. So what will happen is the amide group will be replaced in this nitrogen. So this will form the dibenzazepine carboxamide. That is nothing but carbamazepine will be formed.